calculate as we did. Give me the data. What is the probability that belongs to the class 1? What we do here, let's do, for example, for the binary. We have two functions. I do these calculations. You see here? I will divide the same thing as the tree classification I did. This one here, I will divide the numerator and denominator by this one, which is the same thing here. We get 1 divided by 1 plus this over this is this. But any constant value, you remember in things, any 2, how we can write 2, please? 2 we can write as E ln 2, same thing, right? Star as E ln star, because E and N, they simplify each other. So exactly what we did here, it will be 1 exponential of minus this logarithm. You get this one. Now, the logistic, the idea is here. We call it the logistic sigma u. What does it mean? Here, the differences should be quadratic. I will just simplify it. The two coefficients.
Can you remove the HDMI cable because we can see?
Well, yeah, come again. It's not clear. Yeah, right. Is it better now? Better? It's getting. I don't know. It's getting. No, It's better now? Okay, so what we do, it's just the logistic one. I will suppose that the two covariants are the same for simplification only. So what will be here? It will be our decisions. You see here, the exponential here, A, it will be a linear one. So what I do, I need to tune the W in order to get a better classification, nothing else. So all what we did before, we simplify. We consider the two covariance matrices are the same, and it will be logistic classification. So it's nothing else. So you see how simple it is. Later on, it's just the way how we calculate. Later on, look here, we have two classes here. If they have different covariance matrix, the boundary should be something quadratic. But here, for simplification, for the logistic one, we suppose the two covariants are the same, so the boundary will be aligned, and we have to classify the density is like a line. You see what I mean? That's all. This one does mean a logistic one. So we need to tune the W here, to tune it in order to get the best separations here. That's all. In terms of calculations here, we suppose the W0 that we are adding here, I will add it as a two product thing. I will add X0 with 1, and here we add W0. If we do the product, we get the same thing here. And how to do the loss functions, I will not give more in details. I will not use it for assessment, but just give you an idea about cross entropy. This is the loss function to do it in a better way. Why we use the loss, this cross entropy? Because look here, if I have these functions here, yes, this is y, it can be 1 or 0. And this is my distributions that I want to make it. When it is y, should be high. When it is 0, should be low. So how we can force my loss functions in this one? Because what is the minimum of this? If you do the derivative and we put it 0, you will find the minimum only when zi equals to yi. So here, when you do the training or the optimization techniques, do you know how to do optimization techniques? Do you hear about gradient descent, Newton algorithm? Did you do a Newton before? For example, sine x equals to x, how to solve it? You cannot solve it by hand, right? It's non-linear. We have to do a coding, writing program to solve it. And this program is following certain optimization technique to find it. We call it gradient descent, we call it Adams, we call it Newton. There's different techniques, okay? So to find this one, we have to solve it. We need to find the derivative here. So what does it mean here? Look, I give an idea, but I'm not going in details. You have a functions. You do. I'm looking for W that give me the right separations. I will do the initialization of W, and I will calculate the loss functions. After what I do, what is the new W that I do initializations is based on the derivative of this one. So the W will be plus the derivative here. What am I going in the direction? If the slope is negative, I have to go in this direction. If the slope is positive, I have to go to the opposite direction. So this is how to find the minimum. But I won't go in details because this is another course. So the idea is here. I want to calculate these functions, we call it the sigmoid one, and most of the class are here, and the other one are the other class. It's just like classification of binary. It is not linear regressions. It's totally different. Okay? Look, for example, here. If I have two things here, if I do it in a normal way, it will be quadratic separation, right? But now we suppose they have the same covariance matrix, so the separation is a line. So what will be my real probability that I want to do? Here in the brown, high for one class and lower for second class. And this we call it, what we call it? Logistic. That's all. So instead of using complex things, I will simplify it as a linear. If you have multi-classes here, you see every classes, it will be separated by a line. So we do it regression, but class 1 versus class 2, class 2 versus class 3, and so on. So you get this shape like B houses. If you want to do it without these assumptions, we keep the quadratic. It will be, see here, every boundaries is like quadratic curve. But if you do the logistic, became something just a linear one. It's simple to do. So this is how we can, you see here, I would do initialization by the weight, and the next one will be previous weight plus the gradient descent, multiplied by certain coefficients. Here all the definitions, I will not go in details. Look here, this is gradient descent. I want to reach the minimum, right? I am at this position here. This is my initial initialization. What will be the next W? Or the next here, for example, W1 is here. The next one, I have to go in these directions because it's going down, so I have to follow it. If the gradient descent is positive, I have to go to the opposite directions, right? Because here I want to reach the minimum. So I have to follow when the slope is negative, right? And going down. So I want to reach this point here. So this is the first one, after the second one, third one, and so on, right? When I reach this point here, what will be the derivative? Zero. I have to stop. But here, when you stop, maybe you are at the local minimum. We don't know if we are in the global or not. So this is the issue of deep learning optimization. Yes?
How can you adjust these stops?
Sorry?
How can you adjust these stops? How can you define these stops?
But this formula here. So this is the proof I'm giving. This one here is exactly this one.
The level, I mean the
Why I put minus? Who can tell me why I put minus? Because if the derivative is positive, I'm going in the positive direction, right? I have to go to the opposite one. Because I'm looking for the minimum. So the minus here is to go to the minimum. If you want to understand this one, try to review a Newton algorithm for the normal function with one dimensions. It's very simple. Take YouTube, you can take 10 minutes. After he will do it in the high dimensions, nothing else. Who did hear about the Newton algorithm? Dichotomy algorithm? Those are techniques how to, because we cannot solve it by mathematically, so it is non-linear. Our background mathematically, it is not enough to solve it. So we need to do algorithm. For example, polynomial of degree 5 or degree 6 and higher, we don't have mathematical background to solve it in algebra. What do we have in algebra? What do you have? Square root, log, exponential, power. So those techniques, we prove it mathematically. It is not enough to solve it. So the same problem is the nonlinear. We don't have the background for it. Maybe in the future. So what we do, we use numerical techniques to approximate the solution, but we cannot get it exactly. Is it clear? So what should be? Look here. Example here. This is the logistic algorithm. So there is also a misclassification here. Look here. The green one is well classified. The green one here is well classified. But those here, they are in the wrong side. This should be red, but I classified low. Okay? The same thing here. Here we are using this separation. This is misclassification. Relation, look here. If you use the linear regressions, this is the formula how the linear regression to optimize it, but it is not our code. Just give you an idea. Look, for example, here. This is the linear regressions. If we have outliers, you see here, it affects the linear regression. Look here, if I remove the outliers, it gives me the right line. If I add outliers, you see here, it pushes my line in the wrong way. So what does it mean? Linear regression is very sensitive to the outliers. But for the logistic, is not sensitive. Maybe the only one it will be this single. I want to change the entire, because looking for the frequency. So the frequency one doesn't affect a lot. Okay? You see here, outliers here still is outliers. The curve will not change a lot. Almost nothing. Another thing, you cannot use regressions, linear regression, when you have something two output. You see here, 0 and 1. You want to classify 0 and 1, you cannot use linear regressions. So this is lots of people, they use common mistake here. Okay? Logistic, when we can use logistic, please? When the y is two value. When you have a lot of value, yes, here we can use the linear regression. It's really big differences. Okay, so let's look at linear. What we have, look at y here. Different value of y, a lot. And what we have, only two values. And again here, you cannot use linear regressions when we have two values. Look here. It doesn't make any sense. But we have to use a logistic to go across most of the point. Clear? So this is also, we can use multi-classes logistic when we have a lot of things, lot of classes, not only two. So the same idea, 2 by 2. I think, so the same idea here to optimize the function. I will not go in details. The same idea how to do the gradient descent, how to updating your weight. Logistic here. You see, for example, here, this is the boundaries here between two classes. But if you look for the logistic, is something sigmoid functions. Okay, I think I'll stop here and we finish in 82 later on. Okay, so what we learned today, what we can do about, first of all, splitting your data, training, validation, testing. We use logistic based KNN, nearest one, Mahalanobis distance, and so on. Okay? So later on we do multi-classes and we do decision tree. Okay? Thank you.
So we have a class